So in this video, we're gonna learn geometric series, which is summation. So in this geometric sequence, I said there's gonna be 3 lectures. First one is finding the nth term. Second one was mean, geometric mean, and today is the summation, okay? So let's do a little bit of a review on the first one. How do you find an? Well, we learned the first term, second term, third term, all the way to, I'll just write one more, right? All the way to an. And the relationship between all of this, the relationship, and actually I'm gonna write the first term with the green one. Okay, this is first term. And the A2 is gonna be, you're gonna times the ratio, okay? So it's gonna be the first term times 1 ratio, right? And then u times r again. So the third term is gonna be a times r square. And then u times r again, and that's gonna be the first term times r to the cube, r cube, right? And it goes all the way to the nth power. So it's the first one, times r, but how many r's? Well, if you look at the relationship between the n, the subscript here, and the exponents 4 and 3, that's 1 less, 3 and 2, 1 less, 2 and 1. So this exponent is always 1 less than the n. So here, n minus 1. So that's how we find an is a times the ratio to the n minus 1 power. So that's a little review on the first lecture. The second lecture, we learned the mean. Okay, how do you find the mean? If there are 3 numbers, a, and we'll call this x, right? And the next number is c. Well, we learned x squared is a times c. So x is plus minus ac. Okay, so that's a little bit of a review. And let's go ahead and start the geometric series today. So it's a summation. You are adding all of the terms in a sequence. So the first one, I'm gonna say, it's gonna be a1, right? Plus the next one is gonna be ar to the first power. The next one, ar squared, ar cubed, all the way to, I'm gonna go ar n minus 1, right? That's the last one. So the one before will be ar, oh, sorry, this has to be a little bit bigger. A times r n minus 2. Does that make sense? Because the exponents are 1 less, right? So we have promised that this is going to be called Sn, S sub n. Okay. Now, what are we going to? We want to, just like we did the arithmetic series here, we're not going to add another Sn, but we are actually going to times. To all of this, we are going to times r, okay? The ratio, right there. So if we do that, this is gonna be ar, right? This is gonna be r times r is square. R squared times r is r cubed. So this is gonna be ar to the 4th power. And then this one's gonna be ar, well, let's see. So r to the n minus 2, and if we multiply another r, this is the same thing as 1, right? So because they are times, we could add all of this, n minus 2 plus 1. Okay, so then that becomes n minus 1. So this one becomes n minus 1. Then what would this become? This is going to be arn. Does that make sense? Because r n minus 1, right, times r n. Okay. Well, actually, n minus to this one. To this one, we're timesing another r, right? So if you look at it, this is same thing as that. So oops, if you look at that, n minus 1 plus 1, they cancel. So you have r to the nth power. Okay, so now what we're gonna do is, in arithmetic sequence, we added, but this time we're going to minus it. So if you can look at this, Sn, well, there's actually 1, right? 1 times Sn. So if we could put 1 minus r, right, kind of factor, 1 minus r, because we're minusing. So, and we could put Sn that way, right? So you have 1 times Sn minus r times Sn, then you can do distribution. So you could take this out, 1 minus r times Sn. That's what I'm doing here. Okay. So what we're going to do is the first term, a1 just comes down, okay? But now look, ar minus ar, they cancel, right? Ar squared minus ar squared, they cancel. Same thing, they cancel. It just cancels that way. And then this one will cancel. And the last, you will have that. So the first term here and the last term will be, they will not be canceled, okay? So then we have that and we have this. Actually not, this is gonna be minus ar to the nth power. Yeah. So if we look at this, we can say this, let me write it a little bit bigger. Okay, so if I zoom it up, it's 1 minus r times Sn equals a1 minus let me say r to n power. But you can see this is a1 times 1. It's the same thing. So what I can do is I can take let's see, 1 minus r n. Well, let me take a out first. Well, they're the same thing. So I'm going to take a out here, right? And then I'm going to say 1 minus r to the nth power. Does that make sense? So if you do distribution, you're going to get that. Equals Sn, we have 1 minus r. Okay, so now I am going to divide the whole thing by 1 minus r. So if I do that, it's going to be 1 minus r. And then it's gone. Okay, so this is the formula. This is the formula to find the sum, the summation of all the terms here in geometric sequence. Now, you should have a question. As you know, the denominator can never become 0 because there's no such thing as a 0 denominator. That kind of number does not exist. So we have to give a condition where r does not equal 1. R cannot equal 1, okay? All right, but let's also think about this. This is same thing as, let me erase this, okay? Now, this 1 minus r, I could introduce negative, and right here, negative, and then I could flip this one over, flip it around, right? Yeah, because if I distribute it, it's going to be minus r and then plus 1. Same thing. Okay, minus r plus 1. Okay, so I can do that. I could also flip this one inside. I can put negative, and then r to the nth power minus 1. Exact same thing. So if I turn it around and then this negative sign comes out here, then what I've done is minus a, okay, and then I flipped 1, r to the nth power minus 1. Okay, so they become positive. So we have this one. The original one is a times 1 minus r to the nth power and 1 minus r, okay? And the second one, I can say, second one, same thing, is Sn is a r and r to the nth power minus 1, and then over r minus 1. Over r minus 1. They're the same thing, okay? Because I flip this one, so that becomes negative, and I flip that one, so that's negative. So negative and negative, if you divide it, it's going to become positive. Okay, and there's a condition once again that r cannot be 1. Okay, then what happens when r is 1? Well, when r is 1, Sn, okay, let's look at that. We have a1 plus a r1 plus a r square, remember, like that. But if If r is 1, if this is 1, this is 1, this is 1, then it becomes a plus a plus a plus a plus all the way to what? A to the nth to the nth term, right? So we can say when n is 1, then Sn equals, they're all a. And how many a's? The number of n. So it's going to be n times a, or you could say a times n. It doesn't matter. Okay, so this is when n is 1. When n is 1, this is it. And then when n is not 1, meaning it's either negative number, r could be negative, or r could be positive, but r cannot be 1 in this situation. Okay, so which one are we going to use here? Well, we can say when this, we can use this, it's just easier, okay? We can use this when r is less than 1, meaning when this is negative, when r is negative. For example, if r is negative 3, 1 minus negative 3, this is going to be 1 plus 3, right? It just makes our calculation easy. So we're going to use that so that we could have a positive number, okay? When r is smaller than 1, then we can use this, okay? This one, when r is bigger than 1, so when this is positive, okay, then we can use this one. Doesn't mean that you cannot use the other way around, but it's just a lot easier this way. So if I were to just summarize this, for you, okay, let me write it down. So first of all, so you can write this in your note, okay? When r is 1, maybe I can write this with a different color. Okay, when r is 1, what you're gonna do is Sn is a plus, a plus, a plus, all the way, right? A to the n power. So this is same thing, n times a. This is what we're gonna use. Okay, 2. When r is not 1, okay? When r is not 1, then we have 2, right? Sn, 1 is a, 1 minus r to the nth power over 1 minus r. And we have another one, Sn, the same thing here, but we flip it around, r to the nth power minus 1, r minus 1. When do we use this? When r is less than 1. That doesn't mean that r has to be negative. It just has to be less than 1. So for example, half. If you put half here, it's not negative, but it still works, half, right? So just make sure that r is less than 1. And here then r is greater than 1. We use this, okay? This is gonna be our formula. So with this, let us solve some questions. Okay, you can pause and then write this down. Oh, before we do that, let's see what this is. Okay, this represents what? The first term, okay? What does this represent? The ratio. The ratio. What does n? What n represent? It's a number of terms. We usually say the last term because that's if there are like 8 terms, yeah, then the number of term is 8, but then also the last one is 8. Okay, so remember that. So if we have the first term, the ratio, and the number of terms, then we can find the summation. We can find the series, sum of all of the numbers in the series. Okay, so with that, let me erase everything. So the first question. So in this geometric sequence, we have the first term to all the way to a to the 10th, a sub 10. So there are 10 terms, okay? Find the sum, okay? Sum of all this. So then we say S10, okay? That's what we're looking for. And what is the sequence? Sequence is 2, -4, 8, -16, 32, ... okay? So let's first find out, in order to use Sn, that formula, we need to know A, we need to know R, and we need to know N. Okay, so A means the first term. So the first term we know is what? 2. Good. And R, what is R? Well, -4 divided by 2, it will be -2. Okay, so we know this, we know that. and also n. Well, we know n is going to be the number of terms. So here we're given 10 terms. So n is 10. Now, since r, here, so you can see, right? Here is a formula. Now, since r is smaller than 1, so we're going to use the first one, which is Sn is a times 1 minus r to the nth power, 1 minus r. So that's what we're going to use. So we're just going to plug in the number, okay? So Sn equals, what's the first term? First term is 2, 1 minus r, okay? R is negative 2, and 10 is, n is 10, okay? And the bottom, 1 minus negative 2, so which is plus 2, right? So this becomes 3 here. This becomes 2, and then it becomes 1 minus. Okay, so for your convenience, you want to memorize 2 to the 10th power. Okay, actually, there's going to be some these exponents that you might want to you should memorize. You should memorize everything from 2 to 1 to at least to 2 to 10. Okay, so this should come as just from your memory. Okay, because you don't want to take time to do all this. 2 to the 10th power equals 1024. So this is 1024. Okay, so that's going to be 2 Sn equals 2 minus 1023. Okay, and over 3. So that will be 2, and you can just do the, you can use a calculator to do this, okay? And so the answer is going to be negative 682. So in this sequence, if you add the first term to all the way to the last term, that summation, the sum is going to be negative 682. All right, let's do just one more. One more. One more question. Okay, the sequence is 1, square root of 2, and 2, and 2, and square root of 2, and 4. We are given a is 1, r is square root of 2, n is 10. So we're going to find 1 through 10 again, okay, as 10. Okay, so what are we going to use? Well, let's look at r. R, this is actually bigger than 1. This is bigger than 1. So when it's bigger than 1, we're going to use this one, with the flipped one. So let's always write down the formula, a times r to the nth power minus 1 over r minus 1. So that's what we're going to do. So let's just plug in. Well, a, the first term is 1. What is r? R is square root of 2, and this is 10th power minus 1. Again, r is square root of 2 minus 1. Okay, this one is 32. Why? Because there's actually, how many of them? 10 of them, right? 10. So if there are 10 of them, if we take out this root, then it's going to be 5 2's, which is 2 to the 5th power. So if 2 to the 5th power is automatically 32. So again, you need to memorize this. So 32 minus 1 is 31. So up here it's going to be 31. And you have square root of 2 minus 1. So what do you do with this? You have to times. So in order to get rid of the roots in the denominator by this, right? Okay. So then if you multiply this, it's going to be I think I've done some. Okay, so here it's going to be 2, right? And this is sister brothers, so they cancel out. So square root of 2 times square root of 2 is 2, times 1 will be minus 1. So down is here is going to be 2 minus 1. This one is going to be 31 plus 31. Okay, so there's no other way to do this, right? Yeah. Okay, so it's going to be, this is 1. The answer is 31 square root of 2 plus 31. Okay, so that will be the answer. Okay.